circular base and then it's pulled up to a point, so a bit like a hat or a traffic cone. And we're trying to find the surface area. So the surface area is pi r squared. Now this is just the base, it's a circle. So we know that the area of a circle is pi r squared. Okay, so that must be the base here. And then pi r l, so L is the diagonal length, is the curved surface area. So it's this area all the way around the edge. Okay, so again, we can just label that. So this first part is the base, and then this second part here is the curved area. So if you're asked to only find one of them, we can then use the relevant part of the formula. So whether it's the curved surface area or whether it's the base. And then when we're finding the volume, that's pi r squared times the height divided by 3. So we have 3 measures that we need to know for a cone. The height, which is perpendicular as always, the radius, and the length, which is the diagonal length that goes along the slanted edge of the cone. So if you were given a question, and for example, you had a height of 4 and a radius of 3 and a length of 5, then you could find the surface area. So we would have pi times the radius squared. Okay, so pi times the radius squared. And then we're going to add to that the curved area, which is pi. So again, times by the radius, which is 3, and times by the length, which is that diagonal length, which we had was 5. So that then gives me my final answer, which is 75.36, and this is centimeters squared since it's area. And if I was trying to find my volume, then it would be pi times my radius squared. So again, that same thing that we had before to start with. And this time it's times by the perpendicular height, or height, which is 4. And then at the end there, I need to divide my answer by 3. Okay, and that's true for any cone or pyramid. So I divide my answer by 3, and that gives me 37.68 centimeters cubed, since it's the volume. Okay, so that's how we would use the surface area and the volume formula. Now, sometimes you might not be given both of these. You might have the radius, which is 3. You might be given this and not given this, in which case you need to find it. Or sometimes you might be given this and not this one. If that happens, we can use Pythagoras to help us find the area, to find the missing length. So if I drew a straight line from the center of my cone to the base, and I connected it up via the radius, I would have a right-angled triangle. So if I know that one of my measurements is 3 along the base, so if I draw this triangle out here, so I know my base is 3, and I know that my height is 4, I could find this using Pythagoras, where I have A, B, and C. So A squared plus B squared is equal to C squared. We know that from Pythagoras. So 9 plus 14 is equal to C squared. So that would give me 25. And if I square root it, I know that C is 5, which is what I had here. Okay. Likewise, if we were given that C was 5, but we didn't have B, we can still use Pythagoras and find the shorter side of the triangle. So always keep an eye out for that. Sometimes you won't be given both, in which case you just use Pythagoras to find the missing length, because for a cone, for the volume and surface area, you do need that slanted height as well as the perpendicular height h.